Hello learners, welcome to this session. This is the ninth session in the series of MCS 221 Data Warehousing and Data Mining. In today's session, we will discuss ETL tools and ELT in data warehousing. So let us see the agenda for today's discussion. We will start with ETL process just for a recap, and then ETL past and present, ETL pipelines, and what are the factors to be considered whenever we try to build the ETL pipelines, types of ETL, and then we will see the difference of ETL versus ELT. So this particular session is just a cue of the earlier session. In the earlier session, we had discussed about the ETL, all the three steps, that is extract, transform, and load of data into the data warehousing. So that particular ETL, we had seen it as a very important component in the overall data warehousing design. So business applications use this particular OLT systems, those are the database management systems, wherein which the primary focus will be on the transaction processing part. They may be reading the data, then writing the data, or else modifying the data. So there will be a kind of focus only primarily to the transaction processing when it comes to the OLTP systems. So they are not efficient at analyzing the things. So you may modify the data, you may read the data, write the data, or else alternate the tables, structures, etc. But when it comes to the OLAP, which is very much nearer to the data warehousing, whenever we talk about the data warehousing, it is a OLAP kind of thing. So these particular OLAPs are very much focused upon the analytical processing. Here, it don't directly focus on to the transaction part. However, whatever the data that is being stored in various source systems, those particular data is being pulled into and then transformed by the ELT process or ETL process and then loaded into the data warehouses. So OLAP are excellent in analyzing, like reading and analyzing. Hence ETL is very much necessary to transform the OLTP information, like the database management system information, into the work with the OLAP, that is the data warehouse. So we had understood the ETL, the importance of the ETL there whenever we are converting the OLTP into the OLAP databases. So during this particular ETL process, information is completely extracted from various relational and non-relational, maybe from MongoDB or maybe from other resources. The extraction part will be pulling into the data, and then there will be a finite component wherein which the transformation, we call that particular area as the staging area. It will be converting the whole data into a readable format, understandable format, integrated format, and then it will be loaded. The whole thing will be loaded into the OLAP data warehouse. So this is how the ETL process that we had seen in the earlier section. And then in this particular past, whatever the data warehouse engineers, what they had done is they had completely hand-coded the ETL process. So in the data staging area, we had seen several kinds of transformations taking upon the data. That too, those arrived from the various source systems. So here, the ETL is not a simple logic because it has to pull in the structured data, non-structured data, semi-structured data, and it has to convert it into a meaningful format before loading it into the OLAP data warehouse. However, earlier data warehouse engineers, what they had done is they used to code the whole ETL process, how to retrieve the data from the source systems, and then how to do the noise reduction in the data, or else how to convert the whole dirty data into the cleansed data. So those particular processes are done manually, that too hard coded using R, Python, SQL, whatnot. There are several languages which supports this kind of coding, and they used to do. However, when it comes to the modern ETL solutions like Xplenty, So this particular explainty will allow the data teams to skip hand coding kind of thing, but it automatically integrate the most popular data sources into their data warehouse. However, it will be having a kind of, for the first time, it will be having a kind of manual intervention wherein which the engineers needs to understand the whole system, the sources system, and then they have to apply this explainty kind of system, and then they'll be automizing the complete ETL process. So this particular ETL process, there is a term associated with the ETL process called as ETL pipeline. Here we can see on the slide, there is a simple ETL example given, pipeline example given over here. Here, a customer orders that too in the SAP systems are existing, and that is the primary source of the data, and then there is a pipeline drawn to the data warehouse, wherein which you can see in between there is the ETL process, and then the customer orders are the primary sources, and then from that particular thing there is a line drawn, or else you can call that is a path, or else a channel kind of thing, which is laid from the source to the destination. Here, the source is the customer order existing, the data existing in the SAP system, and the destination is the data warehouse, that is the OLAP data warehouse. So here, ETL is the in-between component wherein which it is transforming the whole data into a workable data or integrated data and is pulled into the data warehouse. So each of these particular end-to-end process is called as a pipeline, right from the source system till the destination system. You can see a kind of pipeline is being laid over. So it is common for companies to have dozens and hundreds of ETL pipelines. So for each and every source system, there may be a special need wherein which they have to lay down a kind of pipeline kind of thing. They have to plan a pipeline of kind of thing wherein which they have to identify the source and they have to identify the destination, and then there will be the ETL process included and the pipeline is being finalized. So these pipelines are created and maintained by data engineering team, or else you can call them as the ETL engineers. So whenever there comes a kind of a new business need, once again the engineers will think of how to what exactly is the source system and what exactly is the destination system, and how to integrate from various sources in order to make it available for the analytical reasons in the data warehouse. So for example, here the new need, the business need may be the combination of data from orders and the results of a recent advertising company. So the data you can see here, it is coming from the orders as well as after some advertisement campaign, how many, what is the increase in the order. So that particular thing also needs to be analyzed. So whenever there is a kind of new business need, there may be a possibility of drawing a new pipeline from the source to the destinations. And let us see, there are certain factors which needs to be considered for building the ETL pipelines. The ETL pipelines most probably may be automized or else may be hard-coded, whatever the reason may be. There are certain criteria which needs to be thought for before laying down the ETL pipelines. So the first thing is the changes to source data. So there may be a change in the data structure or the schema. So these particular changes needs to be addressed. So from time to time, the schema of a data source may be changing and this needs to be addressed. How will the pipeline handle this particular change? So once the structure of the data table in the source may be changing, or else the schema might have been changed in the source data. So obviously how to take care of that particular thing in the ETL component, that is the first thing that one needs to, that is the first factor one needs to think of. And then the transformation dependencies. So pipelines typically involve multiple steps. It is not a single step. You can see you have to identify the source or sources, and then you have to see how the data is being pulled into, and then what kind of noises needs to be reduced into the ETL. So there are several steps included into the ETL stage. So this particular pipelines typically involves multiple steps and each step dependent on the outcome of the previous step. So for example, here the determining the closest data warehouse to the customer first depends on the geolocation, whether the geolocation of the customer is being properly identified or not. So everything is a kind of dependent factor over there about the geolocation. In order to identify the closest warehouse for the customer, you have to have first of all the geo components, geolocation components or else coordinates available with you. When a step fails or produces an unexpected output, how will dependent steps handle this behavior? So that is how we have to take care whenever the transformation dependency factor is being considered. Next comes the change in the priorities. So it is common for the pipelines to evolve over time, and as one step in a pipeline changes, so we told that there are multiple steps involved. So one step, if at all there is a change in one step, how it will impact the other steps, that also needs to be analyzed into the other downstream steps, and then you have to address all those particular things. Once the first step itself is being changed, obviously it may or may not impact the other steps. You have to look into the changes into the pipelines. For example, a pipeline is enhanced to pull data from a third-party source that provides traffic data. So how will this addition of this new data affect downstream processing? So this particular thing is a new thing, and then upon the change, how this particular thing will be changed across, like changed in the downstream pipeline. So those needs to be addressed. And the fourth one is error handling. Sometimes while the ETL process, or else while pulling the data and then sending it to the ETL is happening, there may be a breakage in the pipeline, just like a kind of issue, corrupted data, or else network failure may be there. So how to handle those particular failures, the error handling failures, and then those needs to be addressed whenever we think of the ETL process. Then comes the performance tuning. Sometimes we may be thinking of having several sources, and then the ETL is being there, and then converting the data or treating the data, cleansing the data. However, there may be some certain performance issues also. So as the data size grows and as processing steps increase, the total time to process a pipeline can become problematic. So we have to reduce, whether the same pipeline can be reduced into two, or else can be queued upon one after the other. Likewise, you have to think, and then you have to performance, just like we do it in the database management tuning. Likewise, performance tuning of all these incoming data needs to be taken care. For example, here we had quoted, when processing a pipeline takes so long that it cannot complete before the next update is scheduled to begin, what is the process for measuring and tuning performance of the ETL process and its pipelines? That particular thing needs to be addressed whenever the things are being delayed. Then comes the issue of the scalability. So here we have to address whenever the data increases, like ETL processing needs to scale in a range of ways. Today the data may be of 600 GB. Tomorrow it may be changing, it in a month's time it may be changing to several TBs also. So how to address these kinds of things whenever the data is highly scaling? So whether to have certain servers in place, in-house servers only, or else whether we have to opt it to the clouds or other kinds of things. So these particular things include the input data size, processing steps, third-party service invocations, and parallelized data loads. So how will this scalability requirements be addressed by the ETL process as the needs evolve? So that is also a common factor that needs to be addressed before selecting the ETL. So when we talk about these particular steps, there are several ETLs, several types of ETLs, or several types of ETL tools. So in the previous prior slides, we had seen that earlier it was hard coded, and later on everything got automated with respect to the ETL processes. So here there are several tools available. Some of the tools are in the range of enterprise software ETL, and second category is open source ETL, third category is custom ETL, and the fourth category is ETL cloud services. This particular enterprise software ETL is nothing but it is a kind of proprietary version. So several software companies are coming up with a kind of products called as ETL products, and they wish to sell and support commercial ETL software products. So these kinds of things are a kind of ready-made kind of packages, that too coming with the proprietary thing, licensing and everything are applicable to this. So they are most matured in adoption and functionality. So most of these products provide the graphical user interface. So that is the best thing that, so you have to, using that particular graphical user interface, what needs to be selected is you have to select the inputs, and you have to select what kind of treatment is required. and you have to select what is the destination data warehouse, or else the OLAP data warehouse. So these are the things which can be configured using the graphical user interface for designing and executing the ETL pipelines. And these particular things support relational databases, non-relational databases like JSON, XML, and other kinds of things. Also, some of them support for event streaming sources such as Apache Kafka and other kinds of things. You can see there are several examples we can quote here when it comes to the proprietary versions, or else you can call them as the enterprise ETL software. One is Informatica Power Center, IBM InfoSphere Data Stage, Oracle Data Integrator, or else you can call it as the ODI. And then from Microsoft, there is one product called as Microsoft SQL Server Integration Services, SSIS. And then AB Initio. From SAP, there is one product called as SAP Data Services. And from SAS, there is one product called as SAS Data Manager. So these are some of the products which can be counted as enterprise ETL software. There are other next kind of category called as the open source ETL. So in this particular open source software, there are certain products which are coming from past 1 decade. So developers are continuously developing these kinds of open source ETL tools. So these tools are completely free to use. One can download and put it onto the server, and then they can use directly without having the licensing and other kinds of issues. So the best benefit we are getting from here is the source code is freely available. So what we do with the source code? It is nothing but we can do tailor-make changes, we can extend the things, we can enhance the things, we can enhance the capabilities, or else we ourselves can code certain things in order to make certain tailor-make changes according to the needs of the organization. So that is the advantage that we are getting from the open source ETL. So these tools vary significantly in the quality. And then you have to, the engineers, whoever are handling the ETL, or else the data team, whichever is handling the data warehouses, they should have minimum knowledge in the programming that is being done in the open source ETL, so that they can make the tailor-make changes for their company. So unlike the ETL tools, those are coming from the proprietary, some of the tools are having the graphical user interface feature, and then design in order to design and execute the pipelines. Some of the examples we had quoted over here, one is the Talend Open Studio. This is purely a ETL open source software. And then Pentaho Data Integration, PDA, Hadoop for big data and other kinds of things. So these are the 3 examples that we can quote for the open source ETL software. And then there is the third one called as the custom ETL. So many companies, what they will do is, if at all they don't have the persons, the engineers, or else the software engineers who can handle the hard coding kind of thing for their ETLs, they will give it as the project to the software companies and they pay for it. So many companies use general purpose programming languages in order to create their own ETL tools on behalf of the company. So this approach has the greatest flexibility. However, this requires users to perform their own maintenance. That is the hardest thing that one has to do. From the company side, they have to look after the maintenance part. They have to build up their own documentation, testing, and perform ongoing development. Here, the possibility is in the dual way. One is that they can put the requirements and give it to a company, or else if at all the team exists within the organization itself, they can train the engineers in order to develop the custom ETL. The difficult part here is the maintenance part, the documentation part, the testing part, and the performance ongoing part. Suppose if the software engineers, whoever are designed, developed, and then configured this particular custom ETL into the company, and if at all they left, so most probably the next team needs to be taken over and they have to look into the maintenance and other kinds of aspects. Here we can give certain examples of languages like SQL, Python, Java, Spark, and Hadoop for the big data kind of thing. So these are certain examples for the programming languages which they can use. The limitation here is the downside is that you will need lots of custom coding, setup, and man hours getting the ETL operational. So the team should work just like so many man hours in order to get into the final kind of outcome and pulled it into the data warehouse. Then the fourth type of ETL is the cloud services. So Amazon is one company which is providing the AWS kind of thing, Amazon Web Services kind of cloud services. Google is one platform, and then Microsoft is one platform with the Azure. They are providing the cloud services. Here, all these three companies are having the ETL capabilities, built-in ETL capabilities. Like earlier we had seen IaaS, like infrastructure as a service, software as a service, platform as a service. Likewise, ETL as a service is also one kind of possibility which they are offering from the cloud partners. So if your data is already in one of these particular three clouds, it would be very much beneficial. So no need of going and hiring another ETL, or else no need of putting another kind of ETL. However, they themselves are providing a kind of ETL facilities which can be used. There are several advantages whenever you incorporate with the same, and as well as there are certain disadvantages also, wherein which once you take the ETL and once the data, all the data is put into their this one, a binded kind of thing is happening, and then we can't come out of that particular binding kind of thing. So these particular solutions are highly proprietary. Why? Because they are being binded over. The data is also lying, the organization's data is lying on the cloud, as well as we had hired the ETL component as a service. So we are being totally bound. And then as they are proprietary, we have to pay for it. The licensing plays a major role. And then work within that particular framework only. Once you want to withdraw the services from that cloud and we want to shift it to the other cloud, once again it will be a greater, and it will be totally a difficult task. For example, here AWS Elastic MapReduce, that is EMR, that is one of the cloud ETL tool. AWS Glue is from the Amazon Web Services. Once again, Amazon Web Services data pipeline is another tool that is available. From Microsoft, there is Azure Data Factory. From Google, there is Cloud Data Flow, Segment, and Stitch. So these are some of the examples of the cloud providers with respect to the ETL tools. Then there is another terminology called as ELT, which is becoming very much popular nowadays. That is called as, here you can see the L and T are reversed. So earlier we called the process as the ELT, and here we are calling the process as the ETL, and here we are calling the process as the extract, load, and then transform. So there is not much difference. However, as the two components has swapped, so first comes the loading part and then comes the transforming part. So extract, load, transform is the process of extracting the data from one or multiple sources and then loading it into the target data warehouse. In that particular target data warehouse, all these transformation kinds of things will be happening. Mostly this ELT is being used for the cloud data warehouses. So most probably the traditional kind of data warehouses, they are not into this ELT kind of thing. However, this cloud data warehouses are into the ELT kind of, they are using the ELT kind of technique. Then the steps here included are, first thing, there is no change. The first step is the extract step, wherein which this works similarly in both the ELT and ETL. This is nothing but you have to extract the data from, it has to extract the data from the various sources, maybe like structured data sources, semi-structured, or else unstructured data sources. Then comes the load part. The ELT differs here within the ETL. Rather than deliver this particular mass of raw data and load it into the interim processing, what it does is it completely shortens the cycle between the extraction and delivery. It directly loads the data into the data warehouse, and later on, if at all the transformations are required, the transformations will be done within the data warehousing only. Then comes the transform, I told you. So this offers more opportunities to mine it for relevant business intelligence in near real time. So here what we can expect is the data may be of very much ready in nature and is being extracted and is being transferred into the data warehouse or else you can call it as the loaded into the data warehouse, and that minimum transformation is happening over there. So here the real-time analytics are possible for these particular data warehouse, these particular things. So here, suppose if the data warehousing is supporting the real-time kind of analytics, this particular ELT is the possible solution for it. So this is the ELT process, database. These are the sources, and then there is extract and directly loaded. And then here, within the data warehouse itself, the data warehouse transformation is happening, and then real-time analysis or analytics is possible. What are the benefits? It gives better results with more efficient effort. Time is very less. It takes much less time when compared to the ETL. It transforms your data transfer, combine data from various sources and formats, manage data at scale. It primarily saves the time and money. So you can see here, this is the left-hand side shown is the ELT process, and the right-hand side is the ETL process. And here in the ELT process, you can see extract, transform, and then the load. And you can call this particular central area called as the data staging area. And here you can see directly only you can see two processes happening. Extraction is one process, and then the loading and transformation is clubbed together into the second process. So when the comparison comes into picture, the load time, obviously it takes significantly longer to get data from source systems when it comes to the ETL, and it takes very less time for the ELT. Transformation time, as much of the data is in the form of usable data, so in the ELT it reduces the time and immediately you can take the analytics from it. Complexity, as you can see, ETL tools typically have an ease to use GUI, but ELT requires in-depth knowledge of BI tools, masses of raw data, and a database that can transform it effectively. So data warehouse support, ETL is better fit for legacy kinds of systems, but ELT is better suitable for the cloud kind of platforms. Maintenance, ETL requires significant maintenance for updating the data, but ELT data is always available in nearly real time. So in this particular session, we had seen the ETL, the process, the steps, and then we had seen the ETL pipelines. And then later on, we had focused on what are the factors that contribute that one has to think upon whenever we go for the ETL, like changes and other kinds of things. And later on, we had shifted our focus towards the types of ETLs available in the market, ETL tools available in the market. Towards the end, what we had seen is we had introduced a new concept called as the ELT concepts, which is just similar to the ETL. However, there is a simple change and a kind of swap in load and transform. And finally, we had seen the differences between the ETL and the ELT. Hope you had understood this particular session, and more you can read it from MCS 221, that is data warehousing and data mining unit 4, and second, like towards the end, you have this particular chapter, whatever that has been covered in the session. Thanks for patient listening.